Hi there. So today we're going to go over resultant forces and just what they are, because sometimes it can be pretty difficult to sort of envision these whenever you first start doing it. So this is more for GCSE level physics, but it's a good revision tool for A level physics as well if you're getting confused. So as we know, forces act on an object. A force is also a vector, which you should know at this point. A vector is something that has magnitude and direction. So if you're going to the right is positive, then going to the left has to be negative. So one of your directions is positive and one of your directions is negative. So your resultant force then is, there's always multiple forces acting on a body. So if you're finding the resultant force, then you're finding the overall force acting on that body or that system. So it's adding up all of the forces acting on that body. So we know from Newton's first law of motion that if there's no resultant force acting on a body of motion, then that means that it's going to continue to move in a constant speed in a straight line, or it's going to stay stationary, whatever it was doing to begin with. So we would know that the forces going to the right and the forces going to the left would be equal in that case. But if it has a resultant force, then it's going to accelerate. But we'll get on to that in a second. So if we look at this body here, I'm going to say this is the positive direction and this is the negative direction then. So resultant force, you just add up all the forces acting on that body as long as they're acting on the same axes. So as long as they're on the straight line, you don't really have to deal with forces at an angle at this point at GCSE Physics. So I would say, okay, well, it's 15 newtons plus 20 newtons plus, and then this is going to be minus 8 newtons because it's going in the opposite direction. So that's 15 plus 20 minus 8, which whenever you put it into your calculator, you get 27 newtons. So that's how you find your resultant force then, acting on your body. The resultant force comes in handy whenever we're talking about Newton's second law of motion, which states that if a resultant force is acting on a body, then that force is directly proportional to the acceleration experienced by the body, as long as the mass remains constant, or as we more commonly see it written, F equals ma. This equation is very important because people forget that F is the resultant force acting on the body. It's not just a force. So that means you have to take into account all the forces acting on this body. So in this case, say this body has a mass of 5 kilograms. So we'll say the mass is 5 kilograms. Then we go, okay, what's the acceleration? So the resultant force is 27 newtons, equals 5 times a. So then the acceleration is going to be 5.4 meters second to the minus 2. Or you might see that written at GCSE level, you'll see that written as meters per second squared. It means the same thing. So yes, we have to take into account the resultant force, not just the force. People tend to take like the force acting forward or something and think that's it. So another thing to sort of be aware of then is if you've got a question where you've got a body like that, say, and you've got a forward force of 40 newtons, but you don't know what the force acting backwards is. So we just put that as X. We don't know what that is, but it's there and there is a resultant force. Then say you know the mass, say the mass is the same 5 kilograms and the acceleration is the same 5.4 meters per second squared. Then whenever you're doing F equals ma, you can fill in your ma fine, that's 5 times 5.4. But your resultant force, you have to fill in like you would do it up here. So it's your forward force minus your backward force. So it would be 40 minus x in this case. And then you would be solving to find x, just like any other algebraic equation that you might have. So that's really, really important, is you're doing your resultant force for your F equals ma. and you're taking into account the forward force and the backward force by doing your calculation like it is up here. That's a very quick run through of resultant forces. Just always remember that resultant force means the overall force acting on the body. So you have to add them all up. So I hope that made sense. Thank you very much for watching, and good luck with your questions.